So welcome back to deploying models, and in this last set of video we will be talking more about the serving, TensorFlow serving. So we're going to talk about how to serve your model using TensorFlow serving, which we've been describing previously as well. So we are going to talk in a little bit more detail about the TensorFlow serving, about the lifetime of a servable. So previously we talked about how the servable handler is able to implement the REST as well as the gRPC APIs, right? So there are actually two mechanisms. So the servable handler actually takes over the role of the NGINX as well as the WSGI gateway that we used in the previous implementation of a REST-based service. So the servable handler, this one over here, can still handle the REST-based services, but the Google actually donated the the gRPC mechanism to open source. So actually, it is not proprietary to Google. It's actually open source software. So gRPC can be used with other non-Google services as well. So that's probably something which you may want to take note of. So, however, of course, this TensorFlow serving architecture works best with trained models that have been created using the TensorFlow framework, because they are assuming that the format of the trained model is in a particular format that's actually compatible with TensorFlow. So if you are using PyTorch or MXNet to do the training of your model, then you're out of luck. It's better to stick to the previous architecture where you use the NGINX to do the service calls and then route that over to the WSGI gateway and then pass it over to your model that you actually created with PyTorch. Maybe the inference engine, instead of using TensorRT, you could use the ONNX runtime, and that's actually accessed through the Flask based server. So back to the story of the TensorFlow serving. So if you are working within the TensorFlow environment, then obviously everything is going to work together very well. Okay, so broadly speaking, the sources create the loaders, which are then going to take the model that's been actually saved earlier and then load it into memory. So the loader is like a bootstrap mechanism. It just basically takes something out from the file and puts it into memory of the computer so that it's actually ready to be executed by the inference engine. And so the sources create the loaders for the servable version, and the loaders actually send as aspired versions to the manager. So once it has been sort of put into memory and is ready to run, this is actually sent to the manager, which will then load it and then makes it ready to handle client requests. So the client request comes in still through the servable handler, but to route that request coming in either through the gRPC or WSGI to the right model, this is actually the work of the manager. So the servable merely handles the call and then routes it to the manager, and then with the appropriate resource handle, we will then route it to the correct model that's been loaded in, and then run the execution engine, the AI inference engine, to return the correct result. So the blue here is the caller specific code, and the green is actually the TensorFlow serving core classes. So this, you can see TensorFlow serving mainly consists of all these loaders and the servable handler, whereas the pluggable implementation are basically dependent on your model and the customizations that you need for your particular train model that you want to run. So to install TensorFlow serving is actually quite a simple process. You just need to TensorFlow serving is not Python code, right? It's actually a high performance server. So you need to use a Linux machine to actually run this. So that's why the Installer is basically apt-get, which is a Linux install command. So apt-get install followed by the name of the server, TensorFlow model dash model dash server. This is actually the name of the package. So apt-get is the package manager for Ubuntu Linux, and you do the install for that. So this would actually run and pick up the right version and then install it into the list of applications. So this is very much like the install process that's common for any Linux application. So if you're on Windows, you may not see this very often, but this is basic way of doing this. It might be necessary to do what you call a sudo, which is to run a command, a privileged command like installing here, because actually normally when you need to install any software, you need to be the administrator or the root of the system. You cannot just install it if you are just a normal user, privileged user, not normal privilege level user. So sudo allows you to actually elevate your status or elevate your privilege level up to the administrator level. So you will temporarily elevate your privilege so that you can actually run this installation command as though you are the root user. Of course, there is a password that you need to actually enter when you do a sudo, and that password is associated with the privilege that you need. Right? So that's basically installation. You can actually find the tutorial and the information in this website or the link down here. So to start it running, once you have already installed it, it's very straightforward. So you just need to find a suitable empty space directory to be the home directory for running this execution. You need to actually set some environment variables, which is the same as what you have in Windows. They are environments, so they are stored as part of the operating system, so any application or script can pick it up and get the values. So normally environment variables, they have a key that's associated with value. So in this case, I'm going to store it in the key model directory. So my environment variable model directory will store the location or the folder where all my models are actually located. Okay, so we start running the TensorFlow serving. So this is where we start running TensorFlow serving and then load a model. After it loads the model, we can then start making requests to it from our application using REST or gRPC. And there are some important parameters that you need to specify. For example, where is the REST API call coming in? So typical HTTP requests actually come in on port 80, but we can configure another port for our application so that we don't confuse it with a normal web request. The model name, this is typically going to be used in the URL because the resource locator is in the URL in your HTTP request. So putting the model name as part of the URL allows us to route it to the right resource. And finally, where's the models being stored, the model-based path. This is the path to the directory where you have saved your model. So to run this server, we will just type in the command and with all the other, so you can see that in this case, TensorFlow model server, and I've actually set the REST API port to be port 8501, which is a non-standard port. Normal HTTP requests come in on port 80, or another very common port being used is port 8080. So this is a very unusual port just for our special application. And then the model name, in this case, we want to call this the fashion model, so it's going to be part of the URL in the request being coming in. And then finally, the location. This is a dollar with the bracket is actually to pick up an environment variable. So earlier on, we stored the environment variable where we actually had the model directory. So this just picks up this same value. Of course, you can just type in the hard-coded value here as well. This is just a more elegant or systematic way of doing it. So we can retrieve the model directory from different scripts. And then we do redirection to save the log messages in server.log, and this shortcut here too is very cryptic, but basically it means that error messages are duplicated and then piped into be displayed in your standard out message. Okay, so don't worry too much about that. There's a no hub here, which basically means that I'm going to not hang up this application. So you'll just run it in the background, right, without actually hanging up the session when it returns. So it's going to be running continuously in the background, and there's actually an ampersand here. The ampersand actually forces it to run in the background as well. In the no hub, just make sure that it doesn't terminate. So the commands, etc., are actually in this tutorial here as well, and you can look at it to see more examples of how you can actually run it. So TensorFlow serving is basically intended to not run like a client application. It's supposed to be running in the background on the server, getting ready for any request that comes in from the client application. That's why it is running like a daemon or running like a service. If you talk about Windows, Windows service, in the Linux world, this kind of background service are typically called daemons. So it's actually running more like a service or daemon mode, so that it's running in the background and ready to serve any requests coming in from the client application. So it never ever stops, right, until you kill it or you force it to stop. Because this is more typical for server applications. It's continuously running. That's why it has to be very reliable. You don't want a software that's running continuously in the background and it's not very reliable and it eats up resource and never frees it. That would be quite bad, because eventually you would need to stop the server and then restart it again. So what does the API look like? So it supports both the gRPC as well as the REST API. So REST API is more familiar to us. So we're going to take a look at this. So the TensorFlow model server supports RESTful API. The request and response is a JSON object. And you can see that the GET request, there's a standard URL format. You notice that the model name is part of that URL. So when you do a request, you have the version number, the models, and then the model name that you want. And then the version is going to be passed to the manager, right? So the manager is going to be able to load the correct version of the model you want to use. And then additional things that you want to pass to it. In terms of parameters, you want to pass to the model to make a prediction. You can also retrieve information about the model's metadata, not the model itself, but information about the model metadata. Now the prediction API, this part previously we talked about how it actually we can get information about the model, and here actually once the model is loaded and we want to make a prediction, we will call a post. So we need to upload the data, right? Because when you make a prediction, not only must you have the model, but you must also have the new data to pass to the model in order for it to make a prediction. And you can see here the URL, again we have the model name with the version, etc. And here we have a colon predict to tell it that actually this particular resource has to do with the prediction. And then within the body is where we pass in the data that's required for the new data that's required to make the prediction. So we can use we can use this particular URL to just test out this REST API in action without having to write our own custom application. So you can try it out. Just have to load in the model serving and then pass it the correct parameters. And we come to a simple quiz time again. So once again, the quiz is for you to answer. So pause at the end of the question so that you can think about the answer before moving on to the next part of the video. The purpose of the ONNX runtime and the TensorFlow serving is similar. However, TensorFlow serving depends on proprietary TensorFlow safe model format. Is this true? A, or is this false? B. So pause this video and then think of the answer and then proceed to the next part of the video. So the next question is ONNX runtime for Python provides a REST API, while TensorFlow Serving does not provide a REST API. A, is this true? Or B, is this false? Again, pause the video before you proceed and answer the question. And we come to the end of the quiz. So here are some references for this part of the course, which is talking about the deployment of models. So there are a number of useful references for the REST-based design of the API. Some tools such as Swagger and Postman. These are two tools that are very useful for working with REST-based APIs. So they can allow you to quickly formulate the requests without writing your own custom application. So you can just type in the URL you want, send the request to the appropriate place, and then see that it will also display what's the response coming back from the server as well. Swagger is more for API design. You also have some tools similar to the Postman. But Postman is meant more for execution, so you can automate the execution of a particular URL and then returning what's the return values that you get from the particular request. These two are more informational. Tutorials point as well as REST API tutorial just talks about how you would design a REST API. So these are not tools. These two are tools. Then we have some references on the prediction serving systems that we talked about at the beginning. So there's actually an article in the ACMQ magazine. And you can also go to the URL earlier that I provided, that you can actually look at the software they talk about, and also the short history. And this is actually at the Berkeley University site, and this is actually similar to this article. As I said, this is the article. This is actually the live document, all right, available from their website. So these are useful references, so I leave it to you to actually take a look at them.
And with that, we've come to the last page. Thank you for your attention.